Hello guys, welcome to Chemistry Lecture 1 on solutions. This will be part 1. Um, YouTube doesn't allow for videos that are over 15 minutes long, as I found out sadly earlier. So now I have to redo this video. Anyway, practice makes perfect, right everybody? Okay, so how is this online, remote learning lecture gonna happen in my classes? Well, for the first part, we're gonna have a video lesson like this one, and the video lessons will have pretty much a lecture, same thing as you see me in class, except less walking back and forth, and pretty much just sitting down and staring at my desktop where the magic happens. So so what's entailed in this remote learning lecture 1? Well, you will receive, along with the video, a lecture sheet. Well, pretty much it's a review sheet, pretty much an outline that details what we're doing in this particular lecture. So while we're doing this lecture, you should have this next to you so we can go line by line on each of the topics that we're going to be covered in this particular lecture. The second thing you're going to be getting is a packet. Now this packet is a reading packet which gives you pretty much an overview of what we've been talking about in more of a, a written format, and also there'll be answers or questions that you need to answer on this particular packet. I'll pretty much explain that to you guys a little bit later. All right, let's get started with our chemistry lecture 1, and it's going to be on solutions. Now, depending on which chemistry class you're on, you're going to be a little bit ahead or pretty much just starting this particular lecture. So for those people who've gotten the first part of this, bear with me. The others have to catch up. All right, so let's get started. Solutions. What are solutions? So you have your outline with you. So let's take a look at the first item, number 1. Solutions are a mixture. It's a mixture, technically. It's a homogeneous mixture. So homogeneous mixtures, as you know, are mixtures that are evenly uniformed, or which means they're mixed. When they're mixed, they pretty much, you can't, they're uniformly distributed throughout the medium. Another type of homogeneous mixtures are solutions. Solutions is a homogeneous mixture. So what exactly is a solution? Well, solutions are made up of two things. It's made up of a solvent and a solute. When combined, gives you a solution. Should have been a better way to do this. Or maybe write it down smaller. First time for everything, right? All right, so you have your solvent, you have your solute, and you have your solution. So what exactly is a solvent? Well, solvent is your dissolving medium. So for example, if you were talking about salt water as your solution, what is your solvent and what is your solute? Well, in this case, the solvent will be water and the solute will be salt. So what is a solvent? It's the stuff you're dissolving it into. And what is a solute? The stuff you're dissolving. Okay? All right. So, oh, by the way, how do you know what is a solvent and what is a solute? Pretty simple. Solvent is most likely the one that's the more of, and solute is the less. For example, you have a gallon of water and a cup of salt. And the gallon is obviously a lot bigger. All right, let's move on. So what is an aqueous solution? An aqueous solution is AQ, and it means it's a special type of solution. There are many kinds of solution, but an aqueous solution, or an AQ, is a solution that has water as the solvent. Okay, so pretty much every time you think of an aqueous solution, oh yeah, it's water with something dissolved in it. All right, so number 4, what are factors that affect the rate of solubility? Well, number 1, temperature. Now, increasing temperature changes the dissolution rate. Now, I know what you're thinking, oh, is that direct? No. actually it depends on the type of substance. We're going to actually talk about that a little bit later on. B, the next factor that affects rate of dissolution is actually agitating the solution, stirring it, shaking it. Pretty much it helps disperse the solute particles and with the solvent to create the solution a lot faster. Surface area is the next one. Obviously, breaking up a particle into smaller particles creates a larger surface area. For example, you could have a cube of sugar versus granulated sugar. Which one of these two will dissolve the fastest? Obviously, this one. Okay, breaking up the solute into smaller particles creates a larger surface area. So let's take a look at temperature and solubility. Now, temperature and solubility depends basically on whether or not you have a solid or liquid or gas. So let's take a look at A first. Solubility generally increases when temperature increases. That's a direct relationship, which means that when if you have a water that is 24 degrees Celsius, that's roughly comfortable room temperature, versus water that is in 100 degrees Celsius, putting your solute in either one of this, which one do you think will make your solute dissolve the fastest? Well, obviously this, right? You probably already know that. For example, when you're dissolving sugar into your tea, warm tea versus hot tea probably will dissolve the sugar a lot faster. Now, in liquids, that's the same thing. For example, if you use honey is a liquid. If you were to put that in cold water versus warm water or hot water, honey will probably dissolve faster in warm water. Now, for obvious reasons, you could probably think of temperature as average kinetic energy of particles. And so when temperature is increased, average kinetic energy of particles increases, so the solvent will interact with the solute faster because as they're obviously moving around faster. Now, gases, on the other hand, is the opposite. That's actually an inverse relationship. Let's take a look at B. Solubility decreases as temperature increases. In gases, when you increase temperature, solubility decreases. So how can we, what kind of examples can we think of regarding that? Well, if you take two, let's say liquids with dissolved gases in it, say soda. Soda is really basically water with dissolved, obviously with other stuff in it, but the main part of soda is really water. And it has dissolved carbon dioxide in it to give you that fizz. If you were to pour soda into 2 glass, put one in the refrigerator, put one in your countertop in your kitchen, come back an hour later, if you were to drink the one in the countertop, you'll realize that all the gases have actually fall out of the solution, and you're now drinking a flat soda. But if you were to open your refrigerator and you drink your soda from the refrigerator that's in the cup, you will realize that although it wasn't as fizzy as before, it definitely will still have some carbon dioxide dissolved in it, and that tells you that temperature is an inverse relationship with gas solubility. Increasing temperature will cause gas to fall out of solution. Well, one of the main reasons is that when the solution is formed, usually the solvent is surrounded by the solute is surrounded by the solvent. And when you increase temperature, gases get agitated. Remember the ideal gas, increasing temperature. They move around and they break away from that they break free from the solvent that is surrounding them. So they actually they're able to escape by increasing temperature. All right. Now let's take a look at the 3 terms regarding solubility. Let's take a look at unsaturated, saturated, and supersaturated. Now, unsaturated and saturated are the two most used words in terms of solution. So what are they exactly? Unsaturated solutions are solutions that have the solute concentration under maximum. What does that mean? It means that there's a maximum amount of solutes that solvents can hold at a given temperature. And unsaturated means that they're below that. Okay? Now, which means that if you were to add more solutes, they will still dissolve. Saturated solutions, on the other hand, are different. It means that under a given temperature, a saturated solution contains the maximum number of solutes that the solution can hold. It means that if you're to add any more solutes, it won't dissolve anymore. No matter how much you stir it, it's just going to fall down into the bottom. And you've probably seen something like this, where if you're trying to dissolve sugar into your tea, you could put a teaspoon of sugar, stir it up, it'll dissolve fine. Put another teaspoon, stir it up, dissolves fine. Maybe by the fourth or fifth teaspoon of sugar you're putting in there, you're gonna get diabetes. Stop that. Eventually, you'll notice that all the sugar just goes to the bottom and doesn't dissolve anymore. The reason why is because it's reached its saturated point, which means that the solute is in its maximum. You can't dissolve any more solutes in it. And the last term is supersaturated. Well, it's exactly what it means. It means that in some cases, under rare conditions, well, not rare, certain conditions, you could actually cause a supersaturation, which means you have over the maximum. But that's usually unstable. The minute you shake or agitate the solution, all that solutes that are over the limit will dissolve, will fall out of solution and go back into the bottom, and then you have a saturated solution again. All right. So what we're going to do right now is we're going to stop this video, because we're going to have a part 2. Again, we're going to have to keep this videos short to under about 15 minutes each. So we're going to probably have another part 2 or maybe a part 3 of this awesome and exciting video. I know.